Okay, so this is going to be the solution to the practice problem that hopefully you've tried already. You just need a little update as far as to maybe an area you got stuck at, or maybe just to check your answer. But either way, feel free to pause it or rewind it. Do whatever you need to do to help. I'm going to go a little bit quicker on this though, okay? So we have our optimization equation, we have our constraint equation. The constraint said that our surface area can only be 48 square inches. We want to optimize our volume. We have two variables, so let's let's replace our h. So what I'm going to do is, on my constraint equation, I'm going to say h is equal to 48 minus x squared all over 4x. When I simplify that, I get h is equal to 12x to the negative 1 minus 1/4 x. Okay? So this is a simplified version of this. Okay? And again, just 48 divided by 4 is 12, and then 1 divided by 4 is 1/4. That's where that came from. Okay? So I'm going to take that and plug it into my optimization equation and say v is equal to x squared times 12x to the negative first minus 1/4 x. And let's see if we can optimize our x value. So before we take the derivative and set it equal to 0, let's just simplify this, right? So if I distribute this, I'm going to end up with 12x. Remember, I'm adding my exponents, so 2 minus 1 is 1, minus 1/4 x to the third. Okay? So that's volume. Let's find our critical points by setting our derivative equal to 0. So I'm going to say 0 is equal to 12 minus 3/4 x to the second. Again, I just took the derivative, set it equal to 0. Okay, so same thing on the last problem. What I'm going to do is bring my 12 over, so negative 12 is equal to negative 3 over 4 x squared. When you take the reciprocal, you end up with 16 is equal to x squared. Okay, so when I take the square root of that, I get 4 is equal to x. By the way, on all of these square root equations, I know in the past we said that, for example, the square root of 16 could be plus or minus 4. We automatically eliminate the negative 4 because there's no way you can have a negative dimension when you're making a box, right? Everything's got to be a positive dimension, okay? So let's figure out what our h is so we can get the final dimensions of our box. We would just say h is equal to 12 over x minus 1/4 x. So just plugging my x back in, I would get h equals 12 divided by 4 minus 1/4 times 4. When you do that either by hand or by calculator, you get h is equal to 2. Okay, so the final dimensions of this box, finding optimal volume, would be 4 by 4 by 2 inches. Okay, hopefully those two examples helped you. Please use those in your notes, or any help that you need, let me know to work through your practice problems today.